This video is just an example problem, and what we're going to be looking at is a strong base problem using an ice table. So the problem that we're going to look at is that we want to find the concentration of the hydrogen hydroxide, calcium hydroxide, and calcium ion, also the pH and the pOH for a 0.100 molar solution of calcium hydroxide. And we're going to be using our ice table to solve this. Alright, so here's a problem that we're going to be looking at. I'm going to go ahead and recreate my ice table so that I have a little bit more room to work. So I'm going to move this over. And let's go ahead and recreate our ice table. Now, the first thing that we put in our ice table is our reaction, followed by our initial, change, and end. Now, in this problem, what we need to do is we need to look up what calcium hydroxide is. Is it a strong acid, a strong acid, a weak acid, a strong base, a weak base? What is it? Based off the fact that it has hydroxide, we know that it's going to be a base. And using our solubility rules, we actually find that this is a strong base. So what that means is that when we write a reaction, it's going to dissociate into its ions 100%. So we're going to have calcium hydroxide, and it's going to break off into calcium ions and 2 hydroxide ion. And that becomes really important. So let's go ahead and finish my table. So we have 2 hydroxide ions. Now, my initial condition says that I have a 0.100 molar solution. So we have 0.100 molar, and we have initially no calcium and no hydroxide. Now, when this dissociates 100%, we're going to subtract 0.100 molar from here, minus 0.100 molar from here, but because there's 2 hydroxides, this is actually going to be minus 0.200 molar, because when this breaks up, it's going to create 0.2 molar of hydroxide. So this 2 is multiplying the concentration. So what my ending ends up being is I have 0 calcium hydroxide, 0.100 molar of calcium, and 0.200 molar of hydroxide. So let's go ahead and start isolating and identifying some of our variables. So as I said before, we know our concentration of calcium hydroxide, and it is 0. We know our concentration of the calcium ion, and it is 0.100 molar. And we also know the concentration of my hydroxide, which is 0.200 molar. The only other thing that we don't know quite yet is the concentration of my proton. Now, there are many ways that you can figure this out. Based off of what I have right here, I'm going to go ahead and instead of figuring out my proton concentration, I'm going to figure out my pOH first. So my pOH is equal to the negative log of the concentration of the hydroxide. So my pOH is going to equal the negative log of 0.200 molar. So I get my pOH to be 0.699. Based off of that, I can now find my pH because I know that 14 equals my pH plus my pOH. So that means that my pH is going to be 14 minus 0.699. So my pH ends up being 13.301. From my pH, now I'm going to find the concentration of my proton, and that's equal to 10 to the negative pH. So the concentration of my proton is going to be 10 to the negative 13.301. And so I get the concentration of my proton or my hydrogen ion to be 5.00 times 10 to the negative 14th molar. So those are all my variables. I have the concentration of my calcium hydroxide, my calcium ion, my hydroxide. I have my POH, my pH, and the concentration of my proton. And so there's just another problem. The main difference with this one is that we were solving for a base, but also this part right here, this 2 in front of here, again, is going to be changing the concentration of my hydroxide. And you're going to be multiplying the concentration by whatever this coefficient is up here. So that's why my concentration for my hydroxide is double the concentration of my calcium ion. Because for every 1 calcium ion I have, I'm going to have 2 of my hydroxides. So you want to make sure that you're multiplying that by 2.